Okay, it is day 6, starting in a few seconds. And go. By the way, I had to fix my initialization script, but it's working now. For example, is that the whole example thing? 288, okay. Doop doop doop. 6 main. Wish I would open as well. Actually, I already forgot the number. 288. Okay. What do they want from me? 0. Deserted island. Time. Allowed. Go farther in each race. Allows the boats. The boat to move. Seconds. To see how much margin of error you have, determine the number of ways you can beat the record in each race. In the example, if you multiply these values together, you get 4 times 8 times 9. Determine the... That's all I'm getting. That's all I'm getting. That's interesting. Number of ways that you can beat the record in each race. In this example, if you multiply these values together, so okay, this the time allowed for each race, so the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. The organizer brings you over to the area where the boat races are held. The balls are much smaller than you expected. They're actually toy balls, each with big buttons on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Okay, boats move faster if the button is held longer, but time spent holding the button counts against the total time. Okay, you can only hold the button at the start of the race. The boats don't move until the button is released. You can only hold the button at the start of the race. Okay. This document describes 3 races. The first race lasts 7 milliseconds. The record distance in this race is 9 milliseconds. The second race lasts 15 milliseconds. The record distance in this race is 40 millimeters, sorry. The third race lasts 30 milliseconds. The record distance in this race is 200. Your turbot has a starting speed of 0 millimeter per second. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per millisecond. Okay, so because the first race lasts 7 milliseconds, you only have a few options. Ah, okay. 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 91. 89. What? I got 2 with the same value? Oh, sorry. Sorry about that. Don't hold the button at all. That is, hold it for 0 at the start. We'll have to. For 1 millisecond at the start of the race, then the boat will travel at the speed of 1 millimeter per millisecond for 6 milliseconds. Which reason does it? Okay. Wait. Yes. 344 and 443. Okay. Since the current record for this race is 9 minutes, there are actually 4 different ways you could win. You could hold the button 2, 3, 4, or 5 milliseconds at the start of the race. The second race, you could hold the button for at least 4 milliseconds and at most 11 would beat the record. The total 8 different ways to win. Okay. Now I'm starting to get it. In the third race, you could hold the button for at least 11, no more than 19, and still beat the record. A total of 9 ways to win. Okay, to see. Okay, this is taking me already 5 minutes just to get this. But there's like a lot of details. 9 ways to win, and then I multiply those together. No more ways you can beat. Okay, so let's think this through. It seems so we have a trade-off, really. We have a trade-off. So we have the speed. So let's say, like, because the race was 7, the values were for 1, 2, 3, 4, 5, 6, 7 seconds, holding that for those times. Here, for 7 seconds, I would have a speed of 0, which gives it 0. Here, I would have for 7 seconds, I would have the speed 7, but I have 0 seconds of travel time, still 0. So you see the symmetry that's happening here. Now 6 seconds of travel with 1 speed, so that's 6. For 2, I will have 5 left, 4, then 3, then 2, and then 1. So really, we want to just multiply the difference between those two and see what is left. That like multiply the differences between those two, and that will be our solution. We also have a certain amount of symmetry. I don't know if that is gonna be relevant. But that seems to be the easiest way right now. So let's start going. I only want the words. Print line. So I have 2 lines. And I don't even care about. Really, these go together, and this is going to be our criteria. So, for I in range length of W0 prints and starting at 1 prints WW0 I. Perfect. So this is time and then threshold. Okay, that's really what it is. I also want them as numbers. I know some others will already be done with it already, but ways to beat. Okay. So time and threshold. Now, I just want to go through each of those for I in range time, J. I can say T even. For T in range of time. If, wait. When distance equals T time minus T times T. We need to make sure that these go together. So that they're together, and if distance is greater than threshold, then ways to beat is plus equals distance. And that should be it already. It's not. Ooh, what did I do wrong? What? No, plus equals 1. Ooh, okay. Sorry. Ways to beat equals 0. Ways to beat plus equals 1. Then ways to beat plus time times equals ways to beat. Wrong. There we go. One gold star. Okay, now the twist. As the race is about to start, you realize the piece of paper with the race time and record distance you got earlier actually just has a very bad kerning. There's really only one race. Ignore the spaces between the numbers for each line. Now you have to figure out how many there are to win in this single race. In this example, the race lasts for... Okay. Total of... Okay, so we're going to have issues with time, maybe? Ways to beat 2. Time equals... or big time 0. Big thresh 0. What I can do is b time times equals b time times 10. No. Yes, times 10 plus int. Oh. No, not just times 10. B time equals B time plus WW0I. And then B thresh is B thresh mod I. And then B time equals int of B time. B thresh is int of B thresh. Print B time, B thresh. So this is essentially all about optimization. T2 is not defined. Yep. Perfect. Now I need to... This is not gonna work. This is gonna work for the... Oh, because that was an accident. Yeah, that's exactly what I was fearing. No! It's just gonna work! Okay, that was it. That was it. Actually, kind of surprised right now. Ranks are not too bad. 10 and 30 minutes. I talked too long reading. The reading really took me the longest. And I did this just to make sure that I understood this correct. But yeah, it's already it. I think I'm a tiny bit in shock because yesterday's was so hard. But yes. Yes, this is pretty straightforward. So, let me talk through what happens. We have these races, and I was really worried about optimization, and it took a tiny bit longer, but not significantly longer. In the second one, I could see like the calculation here. We can see that it takes longer here, but it's completely still acceptable. I was gonna start to think about how can I optimize this thing that we would get to a solution. Because yeah, this is acceptable. This is not huge. This really isn't huge. But yes, so we have 3 races here in the example. Here in my thing, we have 4 races. That's why 89 and 89. That's why these have 2 different values. That really confused me at first. But I guess it also makes sense because we want to know the number of ways to win. So all of this is good. In the first one, all of these numbers were different. In the second thing, it was all one number, and we just ignored the white space, which is helpful. And I guess I didn't need to do this. I could have just taken the white space out. But no, yeah, that's fine. And the point was, hey, you have a button on this boat, and you keep the button pressed for amount of milliseconds. And the longer you press it, the more milliseconds, meters per milliseconds does it travel. But it takes obviously that time up from the actual race. So if you have a 7-second race, and then you press a button for 3 milliseconds, you can only race for 4 milliseconds. However, those 4 milliseconds, you have the speed of 3 milliseconds, 3 meters per millisecond. So you travel a distance of 12. And the beautiful thing about this is that as the numbers progress one way upwards, they progress the other way downwards over here. So you have this beautiful symmetry, and it's just the difference of the total time, which is 7, and then the time that you press the button, and then the difference between those two, and you multiply this together. And that's as simple as the math really is. Right? So we go through each of the races at first, and we already construct here the big time and the big threshold for the last one, which is the race altogether. Then I have WTB, ways to build, ways to beat, actually, starting at 0. Here's the time and threshold for this race, and I just go through each of the times. The distance I can go with it is time minus t, so the total time that I can travel, let's say 7 again, minus the time that I pressed it, which is 3. That's now 4 seconds left of travel time. And then if I press it for 3 seconds, then that is multiplied by 3. That's the distance. And if the distance is greater than the threshold, or in other words, we beat the record, then we found a way to beat it. Now at the very end, after we found all the ways to beat it, we multiply it with our answer, ways to beat, which here needs to be 1 because we're multiplying. And then we have the answer. And then we do the exact same thing for the big time. It just takes more computational power, but it's still no issue. Here we need to have it 0 because we're just adding to it. And really, that's it. That's really all this is. This is not difficult at all. So I hope this was helpful. And let me do a time of research. Okay, his solution is pretty much the same thing, just that he runs through a function to do this. He's building up his big times as well. I think one thing that is interesting is how much more good they are at building these arrays in line. And actually, this is way better than my mapping stuff. So I have not mapped here because I really didn't need to. Excuse me. But if I go back into some of my previous days, here, these types of mappings, I wonder if that's way better if I can just do winning equals int x for x in winning dot split. So because for some reason there's a class list. Oh, because yep, here it works. So it should probably work. And this is way better than my whole map and list stuff. So I definitely want to practice this. So yeah, again, my way of learning something and making sure that I improve. But yeah, I hope this has been helpful and you have a good day. Auf Wiedersehen.